Certain components in Reforj cause delay. But which component do you think causes the most delay? Take a moment and guess. When circuits were first introduced to the game, I thought inverters had the most delay, because that's where it was most apparent to me. But I was wrong. And this might surprise you even more, because it's actually none of them. To find out what was really happening, I built 4 signal paths containing 50 main components each. All 4 paths are connected to the same lever through identical 7 component trigger chains, ensuring every signal starts at the same time. The only difference between the paths is the type of main component used. If one component introduces more delay than the others, its signal should arrive later. But as you can see, that's not what happened. All 4 signals arrived at exactly the same time. So now we can come back to my initial question: which component causes the biggest delay? Note that the OR gate wasn't included in this footage, but it yielded the same results. Based on these outcomes, there is no visible difference in delay between the components, which means my answer was wrong. So if the component type doesn't determine the delay, we need to go one step further. Maybe it's not about which component we use, but how many components the signal has to pass through. To test that, I built another 4-path experiment. The same trigger chain as before. This time each path ends with 1 extra repeater, so the output strength is consistent. The difference is in the main path. One path has 50 repeaters, while the other paths travel the same distance with far fewer components. This time there's a clear difference. The shorter paths arrive first, while the longer paths arrive later. One interesting detail is that the receiver emitter path takes longer than the inverter path, even though both contain 6 emitters or inverters. My suspicion is that the receivers also are contributing to the delay, effectively making this a 12-component path rather than a 6-component path. The number of components appear to influence delay. In the previous experiment, we already compared repeaters and inverters, but those paths only contain 6 components. This time I want to amplify any potential difference in changing signal states. So I built 2 signal paths over 100 components long with spacing between each component. One path uses repeaters, while the other one uses inverters. If changing the signal state introduces additional delay, we should be able to see it here. Once again, both signals arrive at exactly the same time. So signal modification does not appear to influence any delay. In Minecraft, the direction of a redstone circuit can sometimes affect its behavior. So I wondered whether something similar might be happening in Reforj. To test that, I built 3 identical repeater paths. One running north-south, one east-west, and one vertically. All 3 signals arrived simultaneously, so it appears direction does not influence delay. Next, I wanted to test whether a signal traveling underwater behaves differently from a signal traveling the same path in open air. To that end, I built 2 identical inverter paths, one submerged underwater and one above water. And again, both signals arrive at exactly the same time. So this also does not appear to influence delay. But I did notice something interesting. If I remove the water from part of the circuit and then place it back again, the signal immediately updates. So while the environment itself doesn't seem to affect circuit delay, changing a block in the signal path from air to water, or vice versa, temporarily influences the signal. So far, we have ruled out component type, signal modification, direction, and environment. The only factor that consistently influenced signal speed was the number of components in the path. And because we found no measurable difference between component parts, it appears that every component contributes the same amount of delay. In other words, what matters isn't which component you use, but how many components the signal has to pass through. But if every component adds the same delay, how much delay does a single component actually introduce? To answer that question, I built several repeater chains, varying the number of components and the distance they cover. The first 3 chains cover roughly the same distance, but contain 101, 51 and 26 components respectively. The last 2 chains cover about twice that distance, one with 201 components, one with just 26 components. I'm running each chain separately, so they don't interfere with each other during measurement. For each chain, I recorded the total signal travel time and divided it by the number of components to get the average delay per component. Regardless of how many components the chain contains, or how far the signal actually travels, the average delay per component comes out the same every time. The number of components is what determines the delay, not the distance. But we've only tested repeaters so far, so I built 5 more chains, each exactly 401 components long, each using a different component type: repeater, inverter, AND gate, OR gate, and an emitter-receiver setup. Same measurement process, same logic. Let's see if the component type changes anything. 5 chains at 40 seconds each would make for a very long video. So this time I staggered the starts. Same isolated measurement, just back to back. Every single component type averages out to the same delay, which confirms what experiment 1 showed visually, now with actual numbers behind it. Across 5 different component types, the average never strays from a tenth of a second. There are small variations between measurements, but these are likely down to frame timing and game performance, nothing that affects the overall conclusion. I started this investigation trying to find the slowest component in Reforj. Turns out that was the wrong question. Across every testable component type, delay is identical. Receivers and emitters are harder to isolate, but the results point in the same direction. Signal modification, circuit direction, environment, none of it matters. What matters in Reforj Title Update 7 is how many components your signal passes through, each one adding a tenth of a second. And one last thing, a redstone tick is also a tenth of a second. Coincidence? Maybe, but interesting either way. Now that we know how circuit delay works, we can predict it before we even build. That changes everything about how we design circuits. No more discovering timing issues after the fact. We can design for delay from the start. And if delay is truly predictable, it opens up some interesting possibilities. Imagine a single timer component. Set it to 0.2, 0.4, 0.5 or even 1 second. But that's an idea for another day. If you'd like to see more Reforj experiments like this one, consider subscribing. Thanks for watching, and I'll see you in the next episode.